This question asks us how to understand the consequences of three forces. There's some kind of block here in the middle. And part A asks to calculate the magnitude of the resultant force. They're using a language, resultant is the same as net force. And let's remind ourselves what a net force is. Net force is simply add up all the forces and see what's left. Some forces cancel each other out, some forces work together, and we should never forget that if there is a net force, it's going to cause an object of some mass to accelerate. So, if you have an accurate drawing, you can estimate what the net force is immediately. These are all vectors, and you can use vector addition graphically. Lay down F1, add F2, F2, bring it here, F2, put it there, there's your F2, then add F3, there's F3, lay it down, and then you go from where you started to where you ended, there's F3, and we expect our F net, which is simply the addition. There's F1 plus F2 plus F3. We expect F net to be right there. So, and we already have an estimate. We think that the result is going to be somewhere right in there. And that's just adding vectors graphically. F1 plus F2 plus F3 brings us to about that point. We expect the resultant force just by looking at the situation, assuming your vectors are drawn with some accuracy. We're expecting the net force to be downward and to the right. We can calculate precisely what it is by solving this equation. Now these are all vectors, and that implies two things. The net force in the x direction is equal to F1 in the x direction plus F2 in the x direction plus F3 in the x direction. So the vectors add up horizontally and they add up vertically. The only thing left is to calculate what all of these components are. Now F2 in my drawing, I'm not going to solve exactly the same problem that you guys have, because I want you, to benefit the most from these videos, you should probably watch the videos, understand it, try to understand what I'm saying, and then put the video aside and see if you can solve the question on your own. And so that you don't just go for my equations or answers, I'm going to make this one just slightly different than the one on the homework. In this case, I'm going to assume I'm given two angles. Here's theta, and here's some other angle, alpha. I think you're given both of those in your... And then there's one vector which lies right on an axis, which you're supposed to know what that angle is. Okay, and all angles are taken from the x-axis in the positive direction. Well, I shouldn't say not always, but there's a tradition in physics of doing that. But those may not be the best angles for us to do these calculations. I'll use more geometric style angles, which are always interior angles, not these exterior angles. Anyway, we need to find out what all these components are. What is the x component of this force 1? What is the x component of force 3? Well, any vector that's on an angle in a coordinate system, you can break into its components. We can ask, here's a vector, it's going up and to the right. Well, we can ask how much to the right is it going and how much up is it going. These components that we draw are always going to be parallel to our vertical axis and parallel to our horizontal axis. So this is the first vector in the y direction. This is the first vector in the x direction. And the vector itself, F1, is the hypotenuse. Similarly, F3 is going upwards and to the left. I can ask myself, how much is it for pushing horizontally to the left, and how much is it pushing vertically upwards? So this is F3 in the y direction. This is F3 in the x direction. It's to the left, and it's upwards, and the hypotenuse is F3. And there's my perpendicular angle. So these are our right triangles, and we know the geometry of right triangles pretty well. So my F1x, this is the adjacent side. I can say that cos theta, I know theta, is equal to adjacent over hypotenuse, and that's equal to F1x over F. I know F, I know theta, I can solve for F1x. F1y, I would use opposite over hypotenuse. Opposite over hypotenuse, I would use F1y over F. Again, I know F, I know cos, I can solve for F1y. So I can now just start plugging those in. I can use similar arguments for F3, but the angle I will use is, I would use this angle here. It's interior to my triangle, and this, because a straight line, the angle through a straight line is 180 degrees, I would be able to identify what this angle is. This would be 180 degrees minus alpha. So I'm just gonna, I'll put a little dot dot in there and say dot dot is equal to 180 degrees minus alpha. So and then I would work with this angle here. And F3, this is the opposite side, this is the x is the adjacent side, and I could bust up F3, similar to these questions here, and come up for values with F3. And start filling in these components. Let's look at F2. Oh, the only caveat is if you use geometry and these little interior angles and you come up with answers, you should recognize that this value is in the negative direction, so that it's going to have F3x is going to actually be negative. F3y is going to be positive, F1y is going to be positive, and F1x is going to be positive. So you should be able to recognize that if you are down here, that this is a negative vertical direction, this is a negative horizontal direction, and so be careful with your signs. All right. Also, let's think about F2. And if we think about the component in the x direction for F2, it's 0. It has no components. It's Fy component, and it's basically its vertical component and the hypotenuse are exactly the same because it is a purely vertical vector. All right, so you can figure out all of these, and you can come up with the net force in the x direction and the net force in the y direction. But that's going to have some result. These are going to be numbers. This is going to be, for you guys, it's going to be something like, it doesn't matter. Let's say it's going to be 2 and -3. So you're going to move out, so you know that in the x direction, your answer is going to be 2. You will have figured out F net. You figure out F net x. And F net y, maybe it's -3. You'll come up, this will be your F net y. This is your F net x. And then, so the result will be this angle there. The resultant force, or the net force. It will be from the origin, the start, to the end. And what is the magnitude of that? That's the first part. Well, you can use Pythagoras. A squared plus b squared is equal to c squared. You know F net x, you know F net y. You can come up with a magnitude for F net.